Hello there, Math Analysis. Now it is time for graphing linear relations. So here is your Chapter 2, Lesson 2 notes video. Here we go. All right. I know I talked about this in the last one, but these three are linear functions. This is only a relation. So I tried to really highlight that everything that's a set of points is a relation. Things that do not also have an x value repeated are functions. And this is an infinitely repeated x value. So that's why a vertical line is not a function. Okay, so just a quick review of our definition of function and relation and why I just refer to this as graphing linear relations, because they're all relations. Most of them will be functions. Only vertical lines are not functions. In the last video, I, of course, went over standard form versus slope-intercept form. And what I did in that is I showed you guys how I convert into y equals mx plus b form every time. So again, that's what I'll be doing today before I'm graphing. Lines are relations if they can't be written in y equals mx plus b form. That's actually part of how I know if I've got a function or not. Okay, so it's kind of neat. I did show you how I get this, how I know that conversion wise from standard form, but I don't use that. So even I, who knows how that came about, don't use that. I put things in y equals mx plus b form. So I highly recommend you do the same. All right, real quick overviews of things that we look at. And here we are, let's graph. Cool. So I graph in y equals mx plus b form. I convert. Here's how we graph lines. Straight edge, right? Ruler, side of a binder, side of a graphing calculator, like side of your agenda book, all of these things, an index card, all could be straight edges. I use a ruler, of course, but you probably should too. It's the easiest way, but still. Convert into y equals mx plus b form. Identify the slope, identify the y-intercept. Notice here I have boxes where I'll write that down, so I'll have that in front of me. Graph the y-intercept. It's a point. Put it on the graph. That's going to be our quote-unquote starting point, even though these lines are infinite. We'll use that as a basis to then count slope. Use the slope to count at least 2 more points of the line, then connect those points using your ruler or straight edge and label in an equation. I don't care which form of the line you label that equation in. It just needs to be labeled with its equation. So it could be the original, so it could be the standard form, it could be the y equals mx plus b form. Either of those are fine, but it has to be labeled. Everything you put on the graph has to be labeled. Okay, let's go. Basics. Okay, so what I'll do is I'll kind of zoom in for each one so we can really be focused on that particular one. All right, so here is my most basic parent function for lines. The reason I say that is because the equation of this line is just y equals x. The slope is the number in front of the x, which is, I always convert into a fraction, 1 over 1. And the y-intercept is the number that's added or subtracted over here. Since there isn't 1, that means the y-intercept is 0. So that means the first point I graph will be 0, 0, or the origin. So I go to the origin, I graph that point. I use the slope to help me count up and right, or down and right, or down and left, whatever my signs are indicating. Both positive, so up 1, right 1, up 1, right 1. I'm going to get a couple more because even though I said just 2 more points are necessary to then create that line, I usually put a couple more. Now, the opposite of up and right would be going back to the y-intercept and going down and left. And notice that is still down 1, left 1, giving me points on that same line. Then, of course, I take my straight edge to this and I graph. Cover the whole graph, arrows at the end, label with the equation. and you're done. Take a sec, breathe it in. Beautiful parent function right there. Nice looking line, if I do say so myself. All right, example 2, y equals negative x. Okay, now we've got a minus sign in front of that x, which means that my slope here is negative. So this is a negative 1 that's really in front of my x. So my slope is negative 1 over 1. We can always take that whole number and put it over a 1 to make the fraction. And I do always label my slopes as fractions. Next, what's this number being added or subtracted at the end? It's 0. So that's my y-intercept. It's 0, which means the first point I graph is going to be 0, 0. All right, cool. Let's go to it. Graph 0, 0, then use the slope to count from here. It's negative 1, so that's down 1, and positive 1, which is right 1. Down 1, right 1, down 1, right 1. Well, let's go back to the y-intercept and try again. What's the opposite of down 1 and right 1? Up 1 and left 1. And look, up 1, left 1, up 1, left 1. I am still getting points along that same line, forming that same line. Because again, if it's a line, it's a constant rate of change. It's a slope, constant rate of change. Connect using my straight edge, arrows at each end, cover the whole graph, equation on the line. Okay? Breathe that guy in because beautiful. Magnificent. Magnificent line. Okay, gave myself a little hint here, huh? Y equals 2. This is going to be horizontal. Think about it. Is there an x variable in this line at all? No. So you're not going to touch the x-axis at all. And if we're not touching the x-axis at all, that's horizontal. That's straight across. So my slope here, because there is no x value, and the number that's multiplied by x is my slope, how I can then have no x value written is that my slope is 0. Now my y-intercept is that whole number added or subtracted at the end. And in this case, that number is a 2. So my y-intercept is 2, which means that my starting point is 0, 2. Because my starting point is always on the y-axis, so its x value will be 0. So 0, 2. Got it. There's my starting point. Now my slope says 0, right? So that means that I don't go up and down at all. In fact, I only go to the left or the right. I just said those backwards of how I went, but that's it. Every single y value of every single point on this entire line is 2. That's why we name the line y equals 2. Infinity. Infinity in both directions. That's why we cover the whole graph. That is why we connect with our straight edge. That is why we put arrows at the end. And then we label y equals 2 because to infinity in both directions, every single point on this line has a y value of 2. This is y equals mx plus b form. That's why this is still a function. Yes, the number in front of your x is a 0, which is why I don't have to write the x. Think about it this way. Y equals 0x plus 2, right? But 0 times x is 0, nothing. So 0 plus 2 is 2. That's why we only write it as y equals 2. Okay, so just kind of think about it that way. Example 4, however, not so much. Example 4, gave myself a little crib note there. Vertical. Okay. Is this x equals 2? Can you ever write that in y equals mx plus b form? No, there is no y. The only variable present in the equation is x. So the only axis I'm going to touch is the x-axis. So I don't have a slope and I don't have a y-intercept. I have an x-intercept of 2, which means the point 2, 0 is what I'm going to touch. Those two other things, they aren't there. So go to 2, 0, get your line on there, or excuse me, get your point on there. Now from here, I'm only going straight up and down because all of the x values on this line to infinity in both directions are going to equal 2. So this point is 2, 1. This point is 2, 2. This point is 2, 3. This point is 2, 4. Let's head down a little bit. This point is 2, negative 1. This point is 2, negative 2. This point is 2, negative 3. This point is 2, negative 4. Every single point on this line to infinity, negative and positive, is going to have an x value of 2, which means that this relation has a repeated x value, which means this is not a function. Toothpaste, not a function. We do still label it with its equation, which is x equals 2. Any lines that are just x equals a number are not functions. They're vertical, they're straight up and down, so the x value repeats to infinity in both directions. That's not a function. These are the only lines that are not functions. All right, great place to stop for a sec and think about it, because I started with 4 very basic line graphs, okay? 4 very basic line graphs. All right, positive slope, negative slope, 0 slope, undefined slope. Started very basic with those. So pause, take it in. Mm-hmm. Obviously, the queen, Cleopatra. All right. Now, let's get into some other graphs. I'll zoom in. We'll focus in on each one. Okay. So example 5, y equals 2x plus 3. All right. The value in front of x, that is your slope. The number by itself being added or subtracted on the end, that's your y-intercept. So here, my slope is 2 over 1, the number in front of x, and I've placed it in fraction form because I just put it over a 1 in a fraction when it's a whole number. My slope is 3. Oh, my y-intercept is 3. Excuse me. That means the first point I graph is 0, 3. Okay, now my slope, being 2 over 1, indicates that I go up 2, right 1, or down 2, left 1. So we're writing that out because we're just kind of reminding ourselves that this is how we graph these lines. On to 0, 3, 1, 2, 3, and up 2, right 1, up 2, right 1. Let's go back to the y-intercept and go down 2, left 1, down 2, left 1. Straight edge, constant slope of 2 over 1 into infinity. Cover your whole graph. Here, I'll just zoom out slightly so you can see the bottom has an arrow too. Cover your whole graph. Arrows at each end. Y equals 2x plus 3. Label. Next. Pause if you need more time. You're doing these with me anyway, but pause if you need more time. Y equals 1/2 x minus 3. Okay, so the slope is 1/2. It's already in fraction form. Negative 3 is the y-intercept, which means that my point I will graph is 0, negative 3. That's where I'll start my graph. And my slope is indicating I go up 1, right 2, or down 1, left 2. So 1, 2, 3, 0, negative 3. Up 1, right 2, up 1, right 2, up 1, right 2. Notice, by the way, the smaller slope here is a less steep line. Okay, I'll compare the two in a sec. I'll zoom out and compare the two in a sec. Back to my y-intercept. Down 1, left 2 goes back the other direction, but still gives me points that are along this line, right? So any of these points are actually on this line, meaning they satisfy this equation. Cover the entire graph, arrows at the end, label with equation. All right? And again, steepness of line, the value of 2 versus the value of 1/2, 2 is a larger value than 1/2, so this slope is steeper. This slope is less steep because the value is less. And that's how slopes work too. Pause when you need to. All right. Down here, y equals negative 2x plus 3. Now, when I go to create my slope, it's the number in front of x still, but it's a negative 2 over 1, which means that when I graph this, it will be down 2 and right 1, or up 2 and left 1. It's got to be one negative move for the whole slope to be negative. My y-intercept is 3, so 0, 3 is the point I'm going to start with. Okay, now from here, down 2, right 1, down 2, right 1. Notice this is a completely different direction from number 5 above it. Back up to the y-intercept, up to left 1. See how that still gives me points that are along this line. And of course, cover the whole graph, use a straight edge, arrows on each end, label with equation. Done. What a beaut. Zoom out real quick. Again, take a peek. Same steepness, opposite direction. And that has to do with the sign in front. They were the same value steepness wise, but they go in different directions. Positive slope, negative slope. Last one, and then you're on your own. Of course, feel free to use this video while you're graphing so you have an idea of what you're doing. Okay, negative 1/2 is my slope. Okay, that means that one negative move has to exist either in the top or the bottom, either one, doesn't matter which. So down 1 and right 2. If I go down, that's my negative move, so that's taken care of. Or up 1, left 2. If you go up, that's positive, so the left is what your negative move is. And of course, negative 3 is my y-intercept, so 0, negative 3 is the point where I start. Always on that y-axis, right? So it's always an x value of 0 when it comes to your y-intercept. So now, down 1, right 2, down 1, right 2. Look at that. Okay, opposite of the slope above it. Go back to your y-intercept. If you go up 1, you go left 2, and you're on the same plane. Up 1, left 2. Up 1, left 2. See that? Use that straight edge to connect. Cover the whole graph. Arrows at each end. Label with equation. There you go. That, my fine friends, and I'll zoom out and show y'all. That is how we graph using y equals mx plus b form. When graphing, have a straight edge present. I have this nice little 6-inch ruler from Staples that I use. It's even broken after years of abuse, right? But this guy, I love. There's another nice 6-incher from, actually this is from an agenda book way back in the day, right? And I use one of those guys. I've always got it present. You can use an index card. You can use the side of a piece of paper. You can use a full length ruler, but use a straight edge. Do not draw these freehand. I will lambaste you if you draw these freehand. Okay. Always cover the whole graph. Don't just cover this little space like this. No, you've got a whole graph. Use the whole graph. Cover. Arrows at the end. We're going infinitely in both directions. There aren't any domain limits on any of these guys. You need to cover the graph. You need to put the arrows on the end. Label with an equation. I don't care if it's standard form or y equals mx plus b form. Label with an equation. It has been yet another pleasure to speak with you. This was the Chapter 2, Lesson 2 notes. Now follow it up with the homework. Come to office hours if you need me. I shall be seeing you, math analyzers. Have fun with your graphs.